Okay, so I'm going to show you the solutions for this Kirchoffs law problem. So we always start off by doing a Kirchoffs current law at one of the junctions, so either at point A or at point D in the picture. And what I'm going to do is I'm going to go through and identify the whole range of I1. So I1, you can see at the top, is going to the left, and I1 can slide like a bead on a wire anywhere between the points A and D. So if I draw arrows, that's the direction that I1 is going. So we'll let I1 be red. I2, that one's fairly obvious. That one's just going left and right, from left to right in the middle branch. So let me go to blue and I'll do I3. I3 is going from A to D. So I3 is my blue current going in that direction. Okay, and then at the points A and D is where those currents meet and mix. All right, so let's do Kirchoffs current law, KCL, and let's do it at point A, and that'll be my equation 1. So if I do that at point A, I can see that I've got the red current, I1, is coming into the junction, I2, the purple one, is going out, and I3, the blue one, is going out. So the Kirchoffs current law equation is in equals out. So I1, oops, switch to my highlighter. I1 is in is equal to I2 plus I3 out. And that's my equation 1. So I've got three unknowns, three unknown currents. I need three equations. So let's go around the loops. We can do, there's three possible loops. We can do the top loop, we can do the bottom loop, we can do the outside loop. Let me go ahead and I'll do the equations for all three of them, and then I'll just solve it using the first two loops. All right, so let me do all the way around the outside. So let me go from, let me see, which direction do I want to go? Let me go from A to B to C to D to E to F. So I'll go in alphabetical order, A, B, C, D, E, F, and of course back to A, back to where I started. So if I start at A, I'm going through that 8 ohm resistor in the opposite direction to the current, and the current, you can see I've got the red arrow there as I1. So the rule is that when I go opposite to the current, it's a positive voltage drop, so it's going to be plus 8 I1. Then from B to C, I go first of all through that 18 volt resistor towards the negative terminal, so it's going to be minus 18 volts. Then I go through the 5 ohm resistor again in the opposite direction to the current, I1, so it's going to be plus 5 I1. And back to D, from C to D, there's nothing. From D to E, there's nothing. Then from E to F, I go through that 36 volt resistor in the negative direction. Sorry, 36 volt battery in the negative direction. So I go minus 36 volts. Then I go through the 5 ohm resistor again in the opposite direction to I3. So that's going to be plus 5 I3. And then from F back to A, there's nothing but wire. So that's my equation, and I'm going to consolidate it. So let's see, I've got 8 I1 and 5 I1, so I've got 13 I1 plus 5 I3, and then I've got minus 18 volts and minus 36 volts, so that's minus 54 equals 0. So there's my equation 2. All right, for equation 3, let's do the bottom loop. So the bottom loop, I'm going to go from A to D to E to F and back to A. So bottom loop, I'm going to go first from A to D. So I'm going to go through in the same direction as I2. So now those voltage drops across the resistors are going to be negative. So I'm going to have minus 11 I2. I go through that 12-volt battery towards the positive terminal, so it's going to be plus 12 volts minus 7I2. And then I'm going to go from D to E, nothing. From E to F, I already did that in the first loop. So I'm going to have minus 36 volts plus 5I3. And then from F to A, back where I started, there's nothing. So I'll set that equals 0 because I've got the closed loop. Combine the terms, so I've got minus 11 and minus 7I2. So it's minus 18I2 plus 5I3. And then let's see, I've got 12 minus 36, so that's minus 24 equals 0. And if I were to do the top loop, so hang on, that's my equation 3. If I were to do the top loop, so that would be A to B to C to D to A. And it doesn't matter which two loops you choose, you should get the same solution no matter what. All right, so let's say A to B, I'm going through that 8 ohm resistor in the opposite direction to I1, so that's plus 8I1 minus 18 plus 5I1. So I already did that for the first loop. Then from D to A, it's going to just be the opposite of what I did for the bottom loop from A to D. So it's going to be going through that 7 ohm resistor opposite to I2. So it's going to be plus 7I2. The 12-volt battery towards the negative terminal, minus 12. Minus 11, sorry, plus 11I2. I'm going in the opposite direction. Equals 0. Okay, so put all that together. So let's see, I've got 18 and 5, so 13I1. And let's see, 7 and 11 plus 18I2. And then 18 and 12 is 30, so minus 30 equals 0, and that's equation 4. So I'm going to solve it using equations 1, 2, and 3. You could equally solve it using any 3 of the equations. All right, so first thing I'm doing is I'm going to take my equation 1. I've got the I1 equals I2 plus I3. I'm going to substitute this equation 1. I'm going to substitute that into my equation 2. All right, so instead of I1, I'm going to put in, instead of I1, I'm going to put I2 plus I3. So I'll scroll down a little bit to do that. All right, so I've got, write down what I'm doing. So I'm going to substitute 1 into 2. All right, so I've got 13 times I2 plus I3 plus 5I3 minus 54 equals 0. All right, so that's 13I2 plus 13I3 plus 5I3 minus 54 equals 0. So combine the terms. So I've got 13I2 plus 18I3. And I'll put the 54 on the opposite side to make it look a little nicer. All right, so I got 13I1 plus 18I3 equals 54. Sorry, that should be 13I2 plus 18I3 equals 54. So you can see it's very, very easy just to make a little mistake like I just did and mess up the whole thing. All right, so now you've got that done. The next thing you do is you solve for either I2 in terms of I3 or for I3 in terms of I2. I'm going to do it, let me solve for I3 in terms of I2. So I'm going to rearrange it. So I've got 18I3 is equal to 54. I'm going to subtract the minus 13I2 on the other side. All right, so I3, now I'm going to divide by 18. And the reason I did it this way is I just knew that 54 divided by 18 was 3, and that was just going to make my equation look a little bit nicer. But you could equally as well do it the other way. All right, so 54 over 18 is 3 minus 13 over 18, I2. All right, so now I've got that equation for I3. Now I'm going to take this version of I3, and I'm going to put this into my third equation. All right, so instead of I3, I'm going to put 3 minus 13/18 I2. So let me scroll up a little bit. I still have equation 3 on there. So I'm going to do minus 18 I2 plus 5 I3. So I'm going to put 5 times 3 minus 13/18 I2. Equals 24. I'm just going to flip that 24 on the other side, just makes it a little bit less cumbersome. So let's see what I've got. I've got minus 18 I2. I'm going to expand that bracket there. So 5 times 3 is 15 minus 5 times 13 over 18 I2 equals 24. Combine all that together, and I get, let's see, I've got 18 plus 5/13/18, so that's going to give me, I'm going to put it in my calculator, 21.61111, so 61 repeating times I2 is equal to 24 minus 15, which is equal to 9. So I2 I'm sorry, that's a negative sign in front of the I2. I2 is equal to 9 over minus 21.61, which is negative 0.4165. And I should round that to 3 significant figures. So that should be negative 0.416, because it's actually 0.41645 something or other. So negative 0.416 amps, and the negative sign just means I guessed the wrong direction. So the current in that middle section actually doesn't flow towards the right, it flows towards the left. Okay, so now I've got an actual number for I2. Now I can, let me switch my pen color here. Now I can take that 0.416 for I2, put it back up in that equation there, and that will give me a number for I3. So let me just scroll down and do that. So I know that I3 is 3 minus 13/18 I2. So now I'm just going to put in my number for I2. And I'm going to get that I3 is equal to 3.30 amps. Okay, and then finally, I know from my equation 1 that I1 is I2 plus I3. So now I can just put in my two numbers for I2 and I3. So I2 is minus 0.416. I3 is 3.30. And I get that I1 is 2.88 amps. Okay, so as long as you go through carefully enough with your algebra and don't mess up your minus signs, you should be able to get the correct answer for it.